Appreciate everybody coming. My name is Scott Lemon. I live up in Heber City, lived out here in Utah for about, 20, 25 years. Used to work for Novell back in the day, and then kind of left there and done a variety of startups, Silicon Valley and Texas and other places, but definitely like living in Heber, so I've hung on to that. Right now I'm CTO at a company up here at American Fork called Dropship.com. Work with Jeremy Hanks, if anybody knows Jeremy. I also have a consulting company, Human Extensions, that I've run for about 10, 15 years with developers offshore and things like that, so both here and offshore. And I've got a startup I'm spinning up now called Woven, which is an Internet of Things startup. I'll plug at the end. I've got a workshop on Saturday. I'm going to be talking about some things in the Internet of Things space. So one thing I wanted to start off with is ask questions. So how many Bitcoin experts are in the room? Okay, so we've got a couple. So I'll start to say to you guys, there are a couple things I'm going to say that you're going to go, well, that's not quite right, but you're going to understand, you know why, because it's a fairly complex technological and cryptographical conversation, and I'm going to try and gloss over some of that to make it more understandable. So I'm going to try to draw some analogies and things to try and get you to envision a little bit about what is Bitcoin and then what is mining and the whole process of mining and getting it to how do you actually make money, or do you make money. Let's see if this can change slides. How about page down? So I'm going to go over an overview of mining, a little bit about coins, and everybody hears about Bitcoin and everybody pictures these coins. Talk about some of the hardware, the pools, exchanges, some of the community stuff, and different strategies on mining and what you can do with it. Now, as I go into this, when Bitcoin sort of first came out, it got a little bit of a blip of news, and I jumped in right away and set up the basic software, and it was real early in the day, and kind of ran it to the point where one day I was rebooting my machine and I just stopped running it. And then over the years I even upgraded that machine and pitched the hard drive and did all that typical stuff. And it wasn't until last year that things really started to pick up again, and I was like, holy cow, what did I miss? And I know people here in Utah that have made millions on Bitcoin. So there are people even here in the state that did very well because they stuck with it from the beginning. I know a couple of them, and they're just grinning. So most of this is all stuff that's very new in a lot of ways post the creation of Bitcoin that I'll be talking about, and it's just been amazing even the last 6 months what's occurred. So one thing that I'm not going to do in here is give you sort of a tutorial of what is Bitcoin, because the overall conversation gets very deep and is kind of long. But I'm going to give a brief overview right now to just say the concept of Bitcoin, first off, is there aren't actually coins. There is no coin, and there is no sort of tracking of the coins. What you're really kind of doing is you have this public ledger of accounts, or addresses as they're called, and addresses or accounts can have balances. So it's not like I actually have a bunch of Bitcoins in my pocket, or even when you say you have a wallet, and I'll talk a little bit about that, it's not like you really have the coins in your wallet. No, the balance you possess cryptographically is out there in these blocks in what's called the blockchain, this public ledger. And everything is cryptographically signed. There's cryptography used in hashing and things like that. And I'll talk a little bit about how that works. But that's the basic idea of Bitcoin. So when I transfer some coins, or I'm going to buy something from you, or I'm going to give you Bitcoins, what I'm really doing is transferring from my address or from my account, in a sense, to your account. And then that's how you then possess them. And you possess them, and in your wallet, you keep the cryptographic keys, the public and private key. So I can transfer to your public key, and you can use your private key to then use them or do other things with them. So what is the concept of mining? So the concept of mining was like as an incentive for people to get involved in Bitcoin. And the mining of Bitcoin is really this computerized guessing game. And that's really what it is. And there's a lot of, if you really are technical and you want to read it, the original paper by Satoshi is amazing. It really is an amazing paper to read, because he goes through methodically describing how this whole system works. And if you have a little bit of background in programming, technology, hashing algorithms, you understand the concepts of public-private key, it's an amazingly simple idea. I mean, there's a lot of detail complexity, but there's some simplicity that just is amazing in there. So what mining is this computerized guessing game, and the guessing game is solving for these hashes, solving a hash, and it's in order to sign these blocks of the blockchain. So as things get cryptographically written, there's this signing process that guarantees that those transactions, those transfers between people are all signed, embedded in the blockchain, and then at that point, the next block gets created, and the next block of transactions, and the next block of transactions. And so miners are out there trying to solve a guessing game of guessing a value that, when added with some transaction data, will actually create a particular hash. Now, how many people are programmers in the room? So everybody knows what a hash is, right? So a hash is actually like a one-way calculation. You can't go from the hash value, the result of it, and discover what the algorithm or the values were to create it. It's one way, at least the ones we're using here. So you're taking some transaction data, and what they do is they actually give you a hash that has to be found. Now, what I've put here as an example is that in this example, they might say you would have to have 3 zeros at the beginning of the hash, and the rest of the digits we just don't even care what they are. Well, anybody who knows hashing, what you have to do is you're taking that data, you're going to guess some other number to put in there with it, and then see if you can create a hash that starts with 3 zeros. Now, anybody who knows hashing realizes that's not trivial. I mean, because hashing, you don't really know what the output's going to be. So you could put a 0, then you could put a 1, then you could put a 2, 3, 4, 5, and you just start guessing, and you do the calculation. Did I get 3 zeros at the beginning? No. Well, then I'm going to guess another one. I'm going to guess another one. Well, I'm going to keep going and doing that. As soon as I, as a miner, hit a hash value that's got 3 zeros at the beginning, I can signal to the community, out to the network, and say, I solved the block, here it is. Well, other miners will do the comparison. They'll see if that number I came up with truly solved for 3 zeros at the beginning, and if it did, everybody agrees and says, great, you won, here's your reward. So that's the kind of high-level description of what mining is. Now, if you think about that as a problem, well, then the issue is, well, how much mining power, how much guessing power can I put at it? It's what's called hashing power. So if I just keep adding tons of hashing power, I can easily, very quickly, increase my odds of solving it before everybody else. So that's pretty easy. Well, what they built in the algorithm was this concept of, oops, I clicked somewhere wrong. Keep hitting the mouse and it doesn't like it. Gotta close this. Now it won't let me get back to the slideshow. There we go. So what they do is, as more hashing power is put into the network and people trying to solve it, well, now they say, guess what? Difficulty is going to go up. Now you have to come up with a number that starts with 4 zeros. So now it makes it that much harder to guess. Well, as that keeps going and more difficulty goes up, they just keep adding zeros and saying, well, you got to guess more and more numbers and come up with one that has more zeros at the beginning. And that's what's called difficulty. And Satoshi designed this in so that as more people try to mine, it doesn't get easier. The difficulty goes up, and it actually makes it more difficult. Now, likewise, if the number of people mining went down, the difficulty would go down. That hasn't happened so far. I mean, not in recent times. Everybody's just pumping more and more mining power into this. So all of this centers on the design of Bitcoin and coins in general. So Bitcoin is the predominant one. It's the one everybody knows about, hears about a lot, but there's a ton of other coins. Now, I'm not going to claim that any of them are value or don't have value or do have value, but it's kind of an interesting idea that in the protocol and the design, the way he made it up, there are these parameters that get set in the protocol. So you have things like the maximum number of coins that can ever be minted or created. You have the block time, or how much time is there to put transactions in a block, and how often do you want those to be solved so that people can actually transact business. And then there's the rewards for solving a block. Those could be continuous, they could be ones that decrease over time. There are what are called these proof of work versus proof of stake, meaning people who actually just do the work and get paid, versus if you actually hold the coins, you can in a sense earn interest with proof of stake coins. So there's all these different parameters that can be designed in, and then there's this hashing algorithm. And so the hashing algorithm is, the predominant ones today are what are called SHA-256, a pretty standard one, and another one called script. The way it came about is that SHA-256 was the original Bitcoin hashing algorithm. It's the calculation done in that guessing. A guy at Google who saw what was going on more recently in the last year or so saw that there was a lot of hardware technology that was showing up that was making Bitcoin more and more difficult to play in, because it was getting more and more expensive to buy the hardware to actually compete and mine Bitcoin. He actually took an algorithm called script that was used in some encryption for backups, and created a coin called Litecoin using the script protocol. And since all this is open source, he just took the Bitcoin source code, modified it to use script, and he created Litecoin, changed a couple of parameters and put it out there. So Bitcoin and Litecoin really became these dominant coins that started to really move. But again, it's all open source. So as it's all open source, then you had people who just took the source and said, well, I'm going to create, Bobcoin and Scottcoin and, there's Jerkycoin and you name it, there's coins. And so people started going out in those directions. Well, likewise, as people got more and more horsepower mining script, people have now started to create even new algorithms to try and defeat hardware conquering or being able to be used to mine these coins. So trying to decrease the amount that you could do this with semiconductors. So you had Bitcoin, a bunch of other coins that fall into that SHA group. You then had Litecoin, tons of script coins that are out there. And now you have these other algorithms and even more coins showing up using those. So the basis of a lot of this is not the coins themselves, but what's called the wallet. And every coin has got a wallet application. It sucks, but my machine at home, I probably have, 40 wallets installed on it, because nobody has actually taken the time to create like a universal wallet. So everybody who tweaks the protocol, changes things in it, basically takes the wallet code from Bitcoin or Litecoin, copies it, modifies a bunch of stuff, recompiles it, maybe adds some cool little graphics to it and things, and changes it to obnoxious colors, and then they release it as their wallet. And so basically you then, in order to play with that coin, to mine the coin, to do anything with the coin, you basically have to pull down that wallet. And again, that wallet is where you're storing the cryptographic keys for your accounts, your addresses. So the wallet becomes the API into the coin. It's both a user interface in the form of an application. So when you download a wallet, you can get that. You can also download the wallet as like a daemon that you can run on a server someplace and only interact with through APIs. Now, one thing I want to mention here as I bring up APIs, one of the coolest things I found about this whole ecosystem is everyone has built APIs in pretty much everything. And it's pretty astounding. Like, well thought up, JSON, web services, things like that. So you can write code very easily to interact with almost any of the components in Bitcoin or any of these altcoins. And once you know how to interact with a wallet for Bitcoin, you interact with the wallet for Litecoin or any of the other coins the same way. It's all pretty standardized. So the wallet stores this blockchain. It stores this transaction list, and there are newer wallets that actually reference the list. So like if you're going to use Bitcoin, you can go get the multi-bit wallet. So it's an HD wallet, and when you run it, it actually doesn't have to download the whole blockchain. It doesn't have to store everything on your machine. It's referencing them through their service out in the cloud, so that you don't have to go through that. But the wallet actually is the component in the system that actually talks peer-to-peer with other nodes in the network. And it's really kind of fascinating. You'd sit there and think, well, how do you bootstrap, anybody who knows peer-to-peer, how do you bootstrap a peer-to-peer network? They actually use an IRC channel. So they connect to an IRC network. They actually exchange information out on IRC. Now, you can have a local config file also, so as you're first starting your coin. But once it gets going, there's a lot of this peer-to-peer that works in the background, and that's how the network talks to itself. That's how all the wallets interact. So it provides you those APIs for interacting with the coin. Some of these wallets actually have built-in mining, so you might turn around and launch the wallet, and it might have a button there that says, hey, you can mine. Most of the times I'm going to warn people, it's probably a waste of time. You're going to heat up your machine. It's going to try and mine on a CPU, and a CPU and a machine just isn't going to mine very fast. It's not competitive anymore. But it is the basis for mining in that when you run a miner, the miner talks to the wallet to get the APIs to get to the network to figure out the work to do to get the information about the blocks that need to be solved. So that mining software is an application that's a separate application from the wallet, most cases. Again, it uses these APIs to get the work. It's to ask and say what work needs to be done, what's the difficulty, what kind of a resolution of a hash do I need to solve, and then it gets to work guessing and guessing and guessing, and if it comes up with that solution, it then posts out through the wallet to the network to say I've got a solution. If the rest of the network, 51% or more of the miners out there agree that you solved it, then you get the reward. So there are several popular mining applications that are out there. Probably one of the first that really took off and just gained ground everybody knows of and is called CG Miner. And so CG Miner is an app that you run on your computer, and it does the actual mining. It knows how to interact with the wallet. It knows how to play the guessing game and try and solve the hash. One of the other big ones that popped up, a guy named Luke created one called BFG Miner. And BFG Miner has really taken off in its support for hardware. Luke is a pretty amazing developer, and he's cranked at just constantly evolving it, iterating it, and supporting all the latest hardware. He runs a pool called Allegis that's a free pool, and I'll talk about those. SG Miner is a new miner that's relatively new. I'd say last 4 months, 5 months. It's a fork of CG Miner where CG Miner started to drop certain support of things. So some people took it, forked it on GitHub, and created SG Miner. Actually, lately it's started to stumble and have trouble as people realize how hard it is to spend your time supporting open source as a hobby. And so Luke is starting to cooperate with the guys at SG Miner to see if he can merge some of their enhancements into BFG Miner. And then you have things like CUDA Miner, which is a variation of them, specializing towards certain hardware. So all of those support similar APIs. It's actually pretty cool. There's a JSON interface that you can just hit it. It's got a little bit of security stuff on it that you can set a password. You can set limits on IP addresses that can talk to the miner. But then you can query it. You can tell it where to mine, what to mine, where the wallet is or where the pool is. You can query it for statistics and things. You can tell what it's up to, the hash rate, how effective it is, whether it's found blocks. So all those APIs are there. And in all of these miners, what you're really getting is variations in the support for different hardware. And that's really what's become the big thing in mining is the differences in hardware. So CPU mining came first. So everybody was doing everything, and that's when I first started playing with it. It was like, okay, run these apps, get it going on my machine, just let it run. A little DOS box, and it was doing its thing. So you're mining on your laptop, and you were doing hashes per second. If you were really cranking, you're going to get up into maybe kilohashes per second. Even on a low-end graphics card, I still dink around with. I got one that's doing like 30 kilohashes per second. At the time, if you were to step back and say, let's go back, 2, 3, 4 years. That actually was effective. But what happened is people realized they could use specialized graphics cards. They could use GPUs. So people started to write the hashing algorithms that would run on the GPU itself. And so when GPU mining started, everybody started to be able to use graphic card. Now you were jumping into kilohashes per second. And if you would gang up multiple graphics cards in your machine, you're getting up into mega hashes per second. So the more hashes per second, it's the more guesses that you're able to calculate and try, so the more effective your mining is. I mean, you can think of mining just like going out gold mining, right? You're digging a hole, it's how big is your digger? You know, you could use a shovel, but if you've got a, you know, big cat diesel or something, you're going to be able to mine a lot more. Well, as people saw what could be done, you know, and the value of Bitcoin continued to go up, people saw where it was going, and once it started to get into the hundreds of dollars, just like anything else, money attracted talent. And so you had semiconductor people who started to look at this and go, well, wait a minute, we can implement a SHA-256 algorithm in silicon, and we could just put it in a chip. And so you started to get ASICs showing up on the market. So the application-specific integrated circuits start showing up, and everybody started to build custom mining gear. And so now they were making custom chips on a small board. Some of them, these units are amazing. They'll make these chips and they're controlled by a Raspberry Pi. I mean, they've got ones that are controlled by a PIC processor. All you needed is a way to have an application like the mining software, BFG Miner, be able to talk to it, hand it down work to do. It would stream it through at full clock speed and spit results out the other side. The chips in this range started, you know, low gigahertz. Now, you know, you're up into individual chips. This next batch, a bunch of people are coming out with, are doing 12, 20 gigahashes per second per chip. So it gives you an idea of the scale of where this is going. So now you're buying a box or, you know, a 1U unit that is way into gigahashes, and now you can easily buy terahash boxes. So trillions of hashes per second that you're putting in a rack, you're turning it on, it's using hundreds of watts of power, but you know, at that point that's not very much when you consider it, and it just sits there and mines. So I figured I'd go through and give you a little bit of an evolution and kind of look at to think about this, but there was a real popular article post this guy did back last year, and he showed how he built his mining rig in a milk crate. And so that became like this super popular meme out there, and everybody he had the whole list and the instructions on this is how to get going on mining and to build a mega hash mining machine. And a year ago, that's a lot of power. So what you're looking at are GPU cards. And down here on the side is a power supply, and those are the power cords going to the GPUs because they need their own power cord. And then in the bottom, what you can't see is where the motherboard is. So you've got the motherboard down in the bottom, and then you use what are called riser cables, and they used to be ribbon cables. You would run the ribbon cable from the motherboard up. And again, I'll say used to, because that's back in the old days last year, right? Now you use USB risers, because someone figured out that you only need a single PCI channel to each card. It only needs 4 wires, so you can use a USB 3.0 cable. So they made a little piece of PC board you stick in the motherboard, a little piece of connector that you stick on the bottom of the GPU, and you run a USB cable down. And so now this is right here just a 3-board rig. So each of these GPUs is probably, I think these ones do about 800 kilohashes per second each. So times 3, you know, you can get more. So the problem is a milk crate, you know, kind of gets confining. So you're thinking about, okay, where else can I do it? So this is a rig I was playing with early on where it's like, okay, I'll start to sit them out and think about what do you do with this? And again, you can see power supply, motherboard. You're trying to keep your costs down. You aren't going to buy a case. You need airflow because these GPUs are hot. And so you just put it out on anything you can do. Well, that takes you to setups like this, right? Because now I'm thinking, wait a minute, I want to set up a rack and I want maximum airflow. I had the baker's rack. So what I've done here is I started to look at, you could sit here and mount the power supplies. You could set up the GPU cards, and I'm just hanging those on Romex, right? Everything's cheap. Had an extra Romex in my barn. So then I've got the motherboards and things. But at this point, once you hit 4 cards, the problem is now power. You max out, that's a 1200 watt power supply, and you've maxed out. The GPUs are consuming more than that. So now you have to do split power supplies. So if you were to look down here, that's a second power supply to this one. Both are ganged up with a little Y adapter down here to the motherboard. So these rigs run at about 1800 watts per rig, 24/7, which ends up being like, $3 a day or something like that, just to run that machine. But then in a baker's rack, the way I looked at it was, you set it up, you could actually get about 10 rigs per rack. Now a rig like this will do about 3.2 to 3.5 mega hashes per rack. So then, you just keep adding them in there and you can start populating and get more. So a friend and I actually worked on this together, and we started putting this together, and we actually found another person who wanted to pay us to actually help him set up rigs like this. So we started to put these together. Now one of the things I started to realize here, and what you start doing, is looking at the economics of it, because you're looking at the investment in the cards, the boards, what you've got there, and then the heat. And heat was the one big element I never even thought about, right? You're thinking about all that power. That's 1,800 watts per rig, and now you've got 4 of those running, and the majority of that heat, that wattage is converting to heat energy. So my basement started to get rather warm, even though this was January, dead of winter. So the next piece, just as a side note, is down on the bottom. These are actually ASIC cubes. So I found a contact in China, a company called ASIC Miner. I got a source through them where I was buying and importing the cubes to start reselling them. And then I could resell those to get my cubes for free. Each one of those cubes is a 30 gigahash cube. And those are doing SHA-256 mining. The ones up above are doing script mining. And so basically you start to just add these things up and you keep pushing up your mining power.
So how many hashes would that whole rack be?
Well, okay, you can do the math for me while I'm here. Let's see. So here you could see once I got the cubes to a certain point, I moved them. So that's what, 18 times 30 right there that's going. So I don't know, I start losing track of where it is, but it starts to approach terahashes. I mean, you're getting close. What was it? So okay, so half a terahash right there just running. Now what was nice is that the efficiency of these is better. They don't get as hot as the GPU rigs do, but again, you start getting an idea. But then the chip vendors keep evolving. So this is one called an Antminer.
How much did those cost? How much did each one?
When?
Yeah.
So the cost, like even by the time I finish this discussion, the cost is probably going to be less. So when I first started with them, they were $600 a piece, and I think I'm getting rid of the last of them now at about $75 each, and that's all since December. So that gives you an idea of how the difficulty has gone up to where that kind of mining is just becoming it's becoming ineffective, because you're getting to a point where you almost can't mine to cover the power cost. And that's really what's interesting, is the science behind mining is evolving to massive calculations and computation around cooling systems and cheap energy, because you really on a small scale just about can't mine effectively anymore. Now, that cube, one cube at 30 gigahashes, was taking up about 250 watts. This is called an Antminer. So I started to sell my cubes, and I was taking what I mined, and I started to convert those to Antminers. So that Antminer is a little bit bigger than a cube, and it does 180 gigahashes. So now you're at 6 times the hash power that I basically was getting with the earnings I made off the cubes, and so I could start to ramp these up. And so now, I've got racks of these there. Now, I don't have too many. I'm not in this in a huge way. I'm doing a lot of this as research, having fun, hobby. I really want to learn and understand it. But I did run into a guy the other day that has 700 of these. So you do 700 times 180 gigahashes, huh? Yeah, and he's with a cooperative and a group of people that put the money in and said, let's do it. And they did it when these first came out months and months back, and they've got racks of them. It's amazing. He shared photos with me. I couldn't find them before the presentation, but you look at them, and I think it's like nine rows or something, or he's got 9 cabinets, 4 per rack, and these are like 3U. So they're just stacked in racks like that. And he even is now trying to sell them because he already sees that the end is coming. And that's because the next sets of chips are coming out. And, to give you an idea, ASIC Miner is about to ship in June their new 12 gigahertz chips. They're producing 8 million of them. So you do 8 million times 12 gigahash, and that's how much hashing power is about to be added to the Bitcoin mining network. And if you do the thought process behind that, then you're going to see that it's like, I forget what, 1,000, 10,000 terahash or whatever, but the difficulty is going to do what? It's going to go through the roof. So once the difficulty goes up, equipment like this will just be obsolete. So that really leads into this whole area of the mining operations. So, you have to look at the way these protocols were designed. That's my pick up my son at school alarm. I did call him and let him know I'm not coming. So in the protocol designs, what they normally have done is said that these rewards also decrease over time. So there was a big epic that happened, 4-6 months ago, which was that the Bitcoin reward, which used to be like 50 coins per block, decreased to 25, got cut in half. Well, there's another halving that's coming. It's out of ways, but it will come again also. So now you not only have all this hashing power and you have this difficulty coming up, but you have the rewards going down. And so you've really got to think about, what are you doing? How can you be effective at doing this and make money at it? So in the beginning, there was solo mining. You ran a miner, and your miner talked to the wallet. It did the mining, and hey, if you happen to hit a block, you got the whole thing. The problem is your probability has gone through the floor now. So there's good calculators out there online. It's so funny because they'll tell you, like, if you took one of the cubes and you ran it in there and you kind of said, how long would I have to mine to, solve a block, that I'd get that whole reward if I was solo mining. And most likely right now it'll tell you, maybe in 150 years. It's like statistically that's the time. I mean, it's way out there. So, the probability is so low at this point that what people started to do, and this started a while ago, was they created pools. A mining pool is just like a mining company, right? You could go out in the desert or go wherever and go gold mining by yourself and try and prospect and find gold yourself, or you could join a mining company that has a wealth of resources and all sorts of miners that all do it in bulk, and at that point you split the work and you split the rewards. And so mining pools are really the way that most people are mining these days. Now, with mining pools, there are two core designs, and this comes down to the typical aspects of denial of service attacks. So the one design is a centralized set of servers that are called Stratum pools. They're using a protocol called Stratum, and with Stratum pools, there's a centralized server, and you point your miner at that pool. And there's really two interesting designs around the authentication on that, like how do you get paid? One design is I go to the pool and they have a website and I sign up and I create an account, and when I point my miner at the pool, I give it my username and password, and that's how they know to credit me with that, with what I mine. The other pools are anonymous pools. And the anonymous pool, you use your address, your Bitcoin or altcoin address as your username. And then they don't even care about the password, because you're now going to be mining using that address, the payout address where you want to receive your payments, as your username. So they don't even know who you are. All they know is they got a connection from a box that says that whatever work he does, pay this address. And so as an example, like the Allegiance pool, that's one of the things they did. There's a number of other ones out there. So that all works until a denial of service attack happens. So people decide that they're going to blackmail the pool, so they just attack the Stratum server and they blackmail the owners and say, we aren't going to stop, your pool's going to be shut down until you pay us. And so then people have to come up with ways to get around denial of service attacks. Anybody in the ISP space knows about that, and so you've got to make that happen. So this other guy out there, I'm drawing a blank on his name, Forrest thought about it, and he created what's called P2Pool. And P2Pool is a peer-to-peer pool where anybody can run a node, and the nodes communicate with each other, and then you can just chain nodes to nodes. And he came up with an alternate algorithm that actually in a distributed fashion divides up the work and handles all of this in a distributed network of peers. And so those are the two key pool types. We've experimented with both. Some have advantages over others. I tend to like the stratum pools better. To me, it's a more predictable pool where I can monitor and know the statistics better. But P2 pool has its place. So the pool now, instead of your miner talking to the wallet to know what work to do, the pool now talks to the wallet. You talk to the pool, you're doing your mining, and what the pool really is doing is saying, okay, if we're going to guess, you do 1 through 10, you do 11 through 20, you do 21 through 30, and it divvies that out to the miners, so you're doing shares of work. So you're doing sub-segments of work to try and solve the block. And so the pool distributes that work across miners and manages that, and at the point that you hit, then the payout is distributed. Now, so it divides that work. Now, there are a bunch of different payout methods. That's the thing you have to realize, and this can bite people, and it's amazing. If you go Google or you look on Wikipedia or the Bitcoin wiki about this, there are these different payout methods like pay per share. Now, pay per share means you're just going to equally divide up. How many shares of work did everybody do, and just equally divide it? Well, that kind of gets hard to manage sometimes because there could be so many shares. So then people came out with things like PPLNS, which is pay per last N shares. So what you're doing is a sliding thing of, if we're going to work on a block, because you don't know, it could take you a minute to solve a block. It's all based on luck. If you guessed good, it could be your first guess hits it and you win the block. But it could be that you work on blocks for hours or a day. So if you are sitting there working and you're working to solve a block and some other pool solves one and another pool solves one, you guys are sitting there working away and your luck just isn't good. You aren't guessing good and you could go this long span of time. What they do on PPLNS is they do a sliding window. So it's whoever did sort of the last N number of shares of work before the block got solved or who get paid. So, and then you get things like PPLNSG, which is where they do these share groups. So they'll say that we're going to, instead of saying it's just sliding over all of time, we're going to look at this as like 15-second increments, and we'll group them in those increments, and then we'll pay out the last N number of increments. But what comes out of that is what's called shelved earnings. So you worked, and people will say, no, we're keeping track of it forever. So if you ever as a pool solved blocks really rapidly, you had great luck, well, they will start to pay off those shelved earnings. They'll start to pay off those old earnings out of the extra winnings, the extra reward. One thing you have to find out is the more you do this, you'll start to get to where you just have to count on the fact that you're probably never going to get paid for those shelved earnings. It's kind of funny. I've got those laying all over the place, and it's just the way it is. You're probably going to lose a good 10% of what you're doing to shelved earnings. It just happens. It's the way luck runs. So pool luck really just decides a lot. And so that's another thing that you look at is, do you want to dedicate all your mining to a single pool, or do you go to multiple pools just to distribute luck across them? Well, then obviously if you do math, you're thinking, but luck is luck, right? So is there any case where you're really going to be luckier in one pool versus the other? It really is just a numerical guessing game. So how do you choose a pool? So one of the things you want to think about is, how big is that pool? Because if you have a very small pool and you're joining it, that pool isn't going to, by luck, by percentage, isn't going to hit as many blocks as a bigger pool. So you really want to look at who the dominant pools are and then decide potentially on other criteria among those pools. Now, one of the other things you want to look at is, what will your percentage of hashing rate be to the pool's total hashing rate? Because what you want to do is join a pool to leverage the power of the pool. Now, if you're the biggest person in the pool and you have the biggest miner, well, you're the one that everybody else is leveraging. So what you want to do is look at that number, and it's not hard and fast, but we generally will target and say, we don't want to be half the pool, but we want to be more than, let's say, 1%, generally trying to aim for even 10% of the pool. Because then at least you're collaborating with other people in a way that you're leveraging each other's hashing power. You aren't the dominant person everybody else is riding. You're able to take advantage of the power of the pool.
Why not more than 50%? Just do your own pool then at that point?
Well, again, it's just, yeah, are you trying to leverage? Who are you trying to leverage? Because you really want to try and join forces with other miners in a way that you know, you guys are all totaling up more than you individually. So the other thing you want to look at on pools is the DDoS resilience. I mean, it is amazing to see the warfare out there and what goes on. It is like real world, and it's a trip. It's all the time, and so different pools have different ways of dealing with it, but pools and mining and all this stuff is under attack all the time, people being blackmailed and ransomed. So you got to look at and start to learn who are the pools that know how to deal with it and the ones that don't. There are then the pool fees. So the people who run the pools will charge a fee. So they could be free, like in the case of Allegis, and they take donations to other pools that are going to charge some percentage. And then there's transfer fees. So a lot of the pools will actually accumulate your earnings, and then they say, okay, when you want to withdraw and transfer it to your wallet or transfer it to an exchange, you have to pay a fee. So that they pick up some money to actually operate the pool. The biggest thing that you want to learn about pools is you want to look at their reputation and you want to look at the amount of their communications. Because the last thing you want to do is set up your miner and let it run and leave and go away, and you come back and, you know, they've been down all day and nobody's talking about it, or they have a bug and they won't respond to you. So the best places are Bitcoin Talk, which is a website. It tends to be where most people announce and talk and communicate, and the pools talk there a lot. The other is IRC. If you aren't on IRC, then I would say you don't really want to participate in mining and stuff, because that's where everything happens. I mean, I've talked to and know almost everybody who's written almost every piece of software in mining and Bitcoin, everything on IRC. I mean, it's amazing to see that they all are there, they're all hanging out, and they're all open to talk to people that aren't complete, you know, idiot newbies. So the other thing with pools are these payout methods. So there are thresholds that you have to hit sometimes. There are payout queues, so you have to investigate and look at those. But in the end, I mean, I haven't really found one versus the other on that I go for or don't go for. But they will have other things like transfer threshold limits. So they don't want to do all the time, like if you're mining some coin, they aren't going to want to sit there and say, well, every coin you can have transfer out of the system. They're going to make you get 1,000 coins of something, or in the case of like Bitcoin, it'd be smaller, but depending on the coin, they'll have some threshold. And then what's nice is they will set up automated transfers. So you can actually say, when it hits this threshold, send it to my wallet, or when it hits this threshold, send it to an exchange. So you can have your miner automatically going. The miner can automatically then be generating coin in that pool, and the pool will automatically kick that out to a wallet or the exchange. And the big thing you have to think about is, where do you want it to go? Now, a lot of the exchanges will say, no, never go straight from mining to us. But a lot of that's historical, where people were sending very small transactions in small increments at rapid rates. So as long as you set a threshold right, like I might go to a pool, I look at how much I'm mining, how much I'm creating in that pool, and I'll say, well, what's the number so that I do maybe 1 or 2 transactions a day? And I'll set that as the threshold and then just let it go. And so at that point, it can flow over to the exchange. So now, what are exchanges? Well, there's tons of people out there who set up exchanges. There's a bunch of popular ones: BTCE, Cryptsy, Bittrex, Poloniex, CryptoRush. There are all these people who have created basically just like stock exchanges. So they will pick a set of coins that they support. They've got the wallets running. You will create an account. They give you a deposit address. You can then transfer in, and they actually run a market. They will have prices in the market that you can see what you can exchange them. Most of the time, you're going to exchange from some coin to Bitcoin, or some coin to Litecoin, or Bitcoin to Litecoin. Those are the predominant anchor coins that you can transfer to. So just about anything you mine, you can normally, at a certain point that coin has a certain valid base, you can start to transfer that over to an exchange, exchange it for some other coin that you want. So they've got buy and sell orders. You can actually set up auto sells. So if you just want to dump the coin you're mining, you can have the pool send it to the exchange automatically do an auto sell, and they'll do things like, well, auto sell at the current price, auto sell at the second highest, or the or the third highest price. So you can actually pick where you want it to sell, and they'll just enter an order for you. If that order hits, then it adds it to your Bitcoin or Litecoin balance, and then you can go in and exchange it. Now, one of the key things about most of these exchanges, there's almost no way to get US dollars. It's always going to be cybercurrency to cybercurrency. So as a side note I wanted to throw in here, there's another site out there that's kind of amazing called Local Bitcoins. Has anybody ever used it? There's a couple people who used it. I mean, it basically, anybody can go do Local Bitcoins. It's a bunch of people who have set up bank accounts where you can go make a US dollar deposit, and they sit in the middle and watch the transaction. So Local Bitcoins will govern how this flows, but you could go negotiate with somebody, say, I want to buy Bitcoin. They offer it a price. You both agree. They give you deposit information. They put the coin in escrow. You go make a bank deposit, and you post the deposit slip, and then they can look at it and release the coin to you. And so you can either be the person who's selling Bitcoin, or you could be the person who's offering dollars for Bitcoin. And so it's all over the country. It's all over the place to do that.
So how do people get rich on this, given that it's difficult to convert to US dollars?
Well, so that's a good question. Let me hit these last slides and then touch on that. So one thing you have to think about is, what's your end goal? What is it you do this for? And for me, it was a big learning experience. I want to know it. I want to know the technology. I actually converted back in December to selling to miners. Like you always hear the 49er story. So I started buying USB riser cables from China and selling the cubes. I mean, I'm selling all kinds of hardware and different things just to do that. But one idea is you want to mine it to hoard the coin. So if you think Bitcoin is really going to take off and be worth something, like I am holding Bitcoin, so I'll go ahead and just keep Bitcoin. And I do use some of it to make some purchases, but I mostly will hold it. One thing you could do is even hold a percentage. We do that with some altcoins. If there's a strange coin we're going to mine, we'll say, let's hold on to 20% and sell 80% for Bitcoin. So we'll hold a certain percentage, because if it ever does happen to take off, you've got that set there. The other is mining to sell. But if you're going to sell, what do you want in the end? Do you want US dollars? Do you want Bitcoin? Do you want Litecoin? Well, if you're going to go to, let's say, Bitcoin, that's really what you want to do, is hold Bitcoin. There are even these other multi-pools that have started up that are really kind of interesting. You can take a script miner that can't mine Bitcoin, add it to a pool that somebody runs, and they don't tell you what they're doing with that hashing power, but they're mining some coin for somebody somewhere, and they turn around and transact it in an exchange for Bitcoin, and they pay you in Bitcoin. So you can now even use a miner that you can't use to mine Bitcoin, but you can get paid in Bitcoin. And so there's a really cool site called Pool Picker. You can go look and you can find all these multi-pools. Or you could do that kind of manually, the same thing. That's where you're manually looking at, like, Coin Wars to look at the coins, what's profitable, have your miner mine it, get it to an exchange, and then transact it in an exchange and convert it. The other one that's come up, and I'm starting to do this now instead, is rig leasing. So I got to the point where I started to question, how do you get rich? I had one coin that I really made money on. There was an altcoin that came out called Mazacoin. And Mazacoin was created by this guy who represented some Indian tribes in North Dakota or something. They were going to do this big deal with it. And, I saw that it was going to be released and mining was going to start. And I was thinking, okay, this is cool. I'll jump on it. And of course, I forgot about it. And it launched on like a Saturday morning or something. And then I turn around and go to an event where a friend of mine looks at me and goes, yeah, that is amazing how much money I just made on that tip you gave me on Mazacoin. And I'm thinking, oh, wait a minute, why? What happened? So he mined it right from the first minute. So I ran home, hours later, and I started mining. But in 5 days, I made about $10,000. So I was able to mine Mazacoin, and I just started selling. I just started dumping it. And so I was able to mine enough and convert. He walked away with about $30,000, $35,000. 5 days. That's it. So pretty good. But rig leasing is where you're leasing your hash power. Somebody else wants it. I don't know why, but you put it to a pool. You agree to how much you want to be paid for it to be there, and they use it. You get paid in Bitcoin. So lease rig came out, beta rigs came out. There's a new one I'm using now that I really like called NiceHash. And NiceHash allows for thresholding. So I can say I'm going to mine, let's say, a Legis Bitcoin pool, but if the threshold goes beyond a certain level, then I want to mine. If they're going to pay me enough, well, then I'll switch and mine to NiceHash. So you can actually set up things like that in the configuration of the miner. So another strategy is just buy Bitcoin. So this comes back to sort of your answer.
All that stuff.
I have sat there and debated after all my learning and after everything I've gone through, it's about even. That's the thing. Except for my one win on Mazacoin, I'd have to say that everything else has been about a wash. Now, what's that? Yeah, I mined a ton of that and actually did pretty well. But
you add a zero every year.
Yeah, see, and that's the thing, is that especially at the price it's at now, because that's the big thing you have to look at, is if you're buying, like a lot of the hardware now, I buy in Bitcoin. So I don't have to worry about how many dollars I spend on it, because the Chinese manufacturers will take Bitcoin. But when I'm spending dollars, if I'm going to spend $400, I'd rather buy a $400 Bitcoin today than to buy $400 worth of hardware that's probably going to be obsolete in a month or 2 or 3.
But that Bitcoin that's $400 a day will be $4,000 a year.
Potentially, yes, exactly. So that's the thing you'll see, is if you're going to take the gamble, it is a good strategy. So one of the keys behind all this, as a wrap up, is just like, do your homework. Like, that's the thing when I got into this and started looking at it, is we really did the math. We have spreadsheets and math to look at everything and all the calculations. Because for Bitcoin right now, there's petahashes of compute power. The figure I thought was great is this second bullet. Right now on Bitcoin alone, there is more compute power on Bitcoin hashing than the top 500 supercomputers in the world combined. So that gives you an idea of just how much compute power is going at Bitcoin. So, it's doing that kind of math, looking at the difficulty. Even when you go out right now, I'd say, would I buy a block eruptor cube today? No. At $75, I don't know that you'd make your money back on it. Like, I'll sell you one. It's fun, but I don't know that you would. But get out on the Bitcoin websites, talk, Reddit. Somebody else mentioned Reddit's got a bunch of stuff, and definitely get on IRC if you're going to do that. Before any last stuff, I'm throwing out my plug. I'm also doing a presentation on Saturday, a workshop on Internet of Things. Whether you go or not, if anybody is into Internet of Things and doing sensor networks and stuff like that, there's a really cool project that's open source from IBM called NoDread. And I'm helping those guys out. We're doing some things. I'm building a product around it. But it's an amazing platform for building different types of event-driven systems and event processing systems. Drag, drop in the browser and runs on anything, so you can run on a Raspberry Pi to a hosted server. I'll see if I got time for questions.
So what exactly are the hashes solving? Like, are we trying to break cryptography? Or what is this doing? That's a good question. So what is hashing trying to solve? So there are coins that have been created to actually try and make it do worthwhile things. So if you were to look at Primecoin does hashing in an attempt to help solve prime numbers. That's still kind of geeky, and I don't know who cares too much about prime numbers but scientists. But then there's another coin called Gridcoin. Gridcoin's actually trying to combine the old what's it called? What's the platform? SETI at Home was written on it. What is it?
Boink?
Yes, Boink platform. So they've tied a coin called Gridcoin to the Boink platform, which is like the SETI at Home thing, so that you're trying to actually solve scientific problems. In the case of Bitcoin, it is kind of a worthless calculation. All it's solving is the signing of the transactions to secure the blockchain. So yes, there's a
difficult for somebody to roll back transactions because they got to do all that work again. It's just proof of work.
Yeah, so that is the thing, is that once it's signed, it guarantees that if somebody wanted to try and forge things in the past, they'd have to recalculate, and so you would not be able to catch up. That's basically it.
Is the difficulty to hash potentially an impediment to doing commerce, though, in the long term? Say they reach the total number that they're totally going to be mined.
So it's another good question. If you run out of coins or these different things are impediments, what's interesting is that the protocol around Blockcoin can be and has been modified. They do have the ability, if enough of the miners all agree, right? If more than half of the network all agrees that as of this date, on this time, or at this point, we're going to change and say there's going to be more coins, or the reward's going to be different, or something else, and everybody agrees and makes that change, then that can happen. And the people who don't agree to it, in a sense, would fork the chain. You'd, in a sense, now have two different coins. So you'd have a group of people who take it and go one way and a group who go the other way. And that's one core thing behind all this is there is no central authority behind all this. So yes, agreed. Now, yeah, and that's a good philosophical discussion on who's really behind it. But theoretically, the way it was designed, it's a 51%, more than half kind of a rule, where as long as the majority of people agree on the protocol, the rules, and how it's played, then that coin progresses down that path.
We need to wrap up for sure.
So I'll stick around afterwards if there's any other questions or anything, and I appreciate your time.